We are now ready to go over the entire refrigeration cycle now that we've learned the components, the pipe connections, and how to take pressure and temperature readings so we can calculate superheat and subcooling. Remember that we will immediately convert refrigerant pressure into saturation temperature. Return air is drawn in through the blower wheel and blown across the evaporator coil, which has cold liquid refrigerant inside. The coil saturation temperature should be around 40 degrees. This cools the air coming out of the supply registers to around 55 degrees. The temperature difference, or delta T, between supply and return air should be around 20 degrees. The refrigerant changes to a vapor state in the evaporator and also picks up about 10 degrees of superheat by the time it travels through the suction line and reaches a compressor as a low pressure vapor. When we add 10 degrees superheat to our 40 degree vapor saturation, the suction line will read 50 degrees. The compressor is what pumps the refrigerant through the cycle. Refrigerant enters it at the corresponding pressure for 40 degrees, which is 118 psi, and it raises the refrigerant pressure to 320 psi. This corresponds to a 100 degree liquid saturation temperature, but the actual temperature leaving the compressor and entering the condenser is extremely hot, over 170 degrees. The condenser fan pulls air from the outside and the condenser starts rejecting heat. The vapor refrigerant first cools down to its saturation temperature of 100 degrees, then it changes state to a liquid and continues to subcool another 10 degrees until the liquid line reads 90 degrees. The liquid refrigerant travels through the liquid line and enters the metering device as a high pressure liquid. The metering device restricts the refrigerant flow and drops the pressure back down to 118 psi, which corresponds to 40 degrees saturation. The temperature also drops too. That is how the evaporator is 40 degrees and can absorb heat, and the cycle repeats.